Payment processing system provides API to process heterogeneous transactions. Here I have very minimalistic transactions that has the amount of money to transfer and IBAN accounts of debtor and creditor. The debtor is the one who sends money and creditor is the receiving part. When I pause this transaction, we receive the following events from our system. The first one is a notification that PPS received a new transaction and assigned pending status to it. The last one is a notification that PPS cannot process this transaction because we haven't enabled its support yet. As you can see, the new status is rejected and the error message is flow not found. The system must know what steps to execute to process this transaction. Thus, we create a flow. Flow describes supported transactions and steps to process them. Our sample flow is super simple. It imitates transferring money between accounts of the same bank. Let's call it bank local transfer. This flow will push the transaction through a few steps. Let's examine them one by one. First, I want system to freeze the debtor's money using my custom step function, and then validate the creditor to ensure it can receive the money. Validation will use another step function intentionally programmed to respond that the creditor account is closed. The payment processing system must be able to handle unsuccessful conditions and prevent them from becoming a failure. That's why I want the system to revert our changes to the debtor account and unfreeze the money after receiving the validation error. The process needs to be observable, so I want the system to signal about processing via the following transaction statuses: pending, freezing debtor amount, validating creditor, creditor is invalid, unfreezing debtor amount, and debtor amount unfrozen. Now, back to our flow. First, I describe supported transactions using Spring expression language. Since our flow describes transfer within the same bank, the debtor and creditor IBANs must have the same bank code. Then I describe the first step, freeze debtor amount. It sets transaction status to freezing debtor amount and then invokes the function freeze amount to freeze money on the debtor account. After the money is frozen, the flow will change the transaction status to debtor amount frozen. Each step can have optional compensation instructions. Here I wrote a compensation execution that changes transaction status to unfreezing debtor amount, invokes step function and then unfreezes the amount and sets transaction status to debtor amount unfrozen. After that, I describe the last step. It sets transaction status to validating creditor, invokes the validate account step function, and in case of successful validation, sets transaction status to creditor validated. Otherwise, creditor is invalid. To register the flow, we use Kubernetes DevOps friendly API. Let's post our transaction one more time. Once we enable support for the same bank transfers, the system can process the transaction. Thus, we have much more events now than the last time. In addition to the event that notifies about a new pending transaction, we also have several transaction statuses changed events, as described them in the flow. The payment processing system exposes several helpful metrics for production usage. On the dashboard, you can see the rate of extension usage. Here we have our sample extension. Also, you can see the rate of incoming messages per step function, rate of outgoing messages per step function, and currently 0 pending messages. Those are queued messages that the system can't send immediately due to high pressure. Also, the system exposes the rate of newly recognized transactions, the transactions with the relevant flow, and the rate of recently rejected transactions, because there was no flow for them. Below are several request-related metrics, including the rate of successful requests, rate of errors, and heat maps for the latency. Also, we implemented a few saturation metrics that shows hardware load and technology-related data. Payment processing is a complicated topic that requires appropriate treatment. As you see, our system is simple enough to be easy to use and extensible enough to be easy to adopt. As adoption includes writing declarative flow and implementing extensions using Flink stateful functions, check out our articles and example projects using this technology.